A1, A2, A3 are the amplitudes. Then if you observe that A2 is the amplitude of reference signal and A3 is the amplitude of the signal received. That means echo signal from a target at a range R0, where R0 is nothing but the range we are going to talk about. Then as usual, Fd is nothing but the Doppler frequency shift. T is nothing but with respect to time. As I said, C is nothing but velocity of propagation. The reference signal and the target echo signal are heterodyned mix in the mixer stage of the receiver, producing low frequency. Here we are going to prefer about the low frequency, that means difference frequency component from the mixture, and is given by, that means the difference voltage is given by, I am going to represent with another amplitude A4. Then I am going to talk about sine of 2 pi Fd into T. Why? Because I have considered here in the mixer stage, okay, the difference component. Okay, then if you observe that there is this part as usual, that means depending upon the range we are going to consider this as usual. Okay, this is the final expression in the mathematical analysis. Finally we have going to perform some mixing operation at the receiver side, especially in the mixture we are going to perform some difference frequency component. Okay, here very important, there are two notes. The difference frequency is equal to the Doppler frequency, as I said. For stationary objects, the difference frequency, that means the Doppler frequency, is 0. Is it clear? This is a mathematical analysis. Okay, I think it is very helpful to you. For the next topics, concentrate this and the mathematical analysis. Is it clear? What is the main intention in the mathematical analysis? Nothing but, okay, we have to pass the reference signal and the target echo signal to the mixture. That means heterodyning operation. Heterodyning is nothing but mixing of frequencies, okay, in the mixer stage of the receiver, producing low frequency, that means difference frequency components from the mixture. And from the mixture we are going to present this type of output. Is it clear? This part here 4 pi Ft or not by C, it is not disturbed. Is it clear? Why? Because it is a range. Is it okay? This is a mathematical analysis. This is the very basic thing for the next topics. If you are familiar with these topics, the next topics are very easy. Is it okay? Okay, these are the two figures what we have discussed. I have just going to show the difference between these two figures. Just you are adding some pulse modulator and pulse amplifier blocks to this simple CW radar, then it is going to convert into pulse radar. Is it okay? Then we are going to consider some example. Okay, if you observe this figure, let us consider this is the echo signal. Let us consider this is the echo signal. Okay, this is the output from the mixture and the Doppler frequency. Okay, let us consider this is the output from the mixture. This is the output from the mixture. Let us consider, or let us consider this is an echo signal. Is it okay? If you observe this and this, if you observe this and this, okay, depending upon the Doppler frequency, if the Doppler frequency is large compared with the reciprocal of the pulse width, if the Doppler frequency is large compared with the reciprocal of the pulse width, that means we are going to consider two conditions. Okay, Doppler shift is greater than or less than with the reciprocal of the pulse width, then we are going to observe the waveforms here. Okay, coming back to the description of this, we are going to consider an example of the output from the mixture when the Doppler frequency is large compared with the reciprocal of the pulse width, and also the Doppler signal may be readily discerned from the information contained in a single pulse. That means I'm going to observe this. Okay, if you observe this, if the Doppler frequency is less than and greater than, if you observe these two, okay, that means if you observe the figure names here, the radio frequency echo pulse train, I am going to talk about, this is the echo pulse train as I said. Then video pulse train for Doppler frequency is greater than the reciprocal of the pulse width. Okay, this is the figure which shows the Doppler frequency is greater than the reciprocal of the pulse width. Okay, if you observe this figure, okay, video pulse train for Doppler frequency is less than the reciprocal of the pulse width. If the Doppler frequency is equal, that means whatever may be the signal we have transmitted, the echo signal is as it is. If the Doppler frequency is greater than the reciprocal of the pulse width, that means pulse width is nothing but I'm going to talk about the transmitter frequency. If it is greater than, if it is like this, if it is less than, okay, if you observe this, we have two signals. That means one is a positive signal, another one is a negative signal. Then I can say that it is a bipolar signal. But we need a unipolar. That why we need some, first of all, we need some filtering purpose here to equal all this, and also we need some rectifier which converts a unipolar into bipolar. Later we are going to add these two blocks in our figures, these figures. Okay, this is a very important and interesting point here. Okay, as I said that there is an echo signal, RF echo signal. It is the greater than Doppler shift signal. That means, sorry, not greater than, here the Doppler shift frequency is greater than the reciprocal of the pulse width. Here the Doppler shift frequency is less than the reciprocal of the pulse width. That means what I'm trying to say here is I'm going to vary how our Doppler shift varies with respect to time. If the Doppler shift does not vary, the output is like this. If the Doppler shift is greater than, the output is like this. If the Doppler shift is less than, the output is like this. That means after mathematical analysis, if you observe this expression, okay, this expression, okay, if you observe this, depending upon this frequency, mathematical analysis, the output waveforms are going to be altered like this. Clear? Okay, then come back to the very important one. Sorry, come back to the very important one here. Okay, why? Because in the starting of this lecture I said that the Doppler shift is going to be separate the stationary targets from the moving targets. Okay, here we are going to use some indicator, PPI, plan position indicator. Then one more indicator here present, a scope. This is nothing but amplitude versus range indicator. What is the amplitude at okay, versus range? That means at this range, what is the respective amplitude? Okay, let us consider moving targets may be differed from stationary targets by observing the video output on this. That means by observing this output, we are going to tell whether it is a stationary or a moving one. Okay, if the target is stationary, we can clearly say that the amplitude should not vary, right? If the target is moving one, the amplitude should be vary. Is it okay? This is the key point here. You have to write this key point in your external. Just you have to write this key point. After this, if you observe this figure A, okay, you have like this. If you observe this like this, like this, like this, like this, wherever there is a flat amplitude, all these are the stationary ones. Wherever there is a variation in the amplitude, those are the movable one. Okay, depending upon the sweep frequency selected, this is going to be vary up to, if you observe this figure, this figure, and this figure, tells the variations of moving and stationary objects. Then this is a very important figure which gives the continuation to the next topics. If you observe the name of the figure, successive sweeps of an MTI radar from A to E. This A, B, C, D, E, successive approximations. I'm not saying those are exact, right? Here if you observe that MTI radar, a scope display. That means I think amplitude versus range. Is it okay? Then finally if you observe this F, okay, there are some superimpositions. That means superpositions. If you observe this, it is looking like in digital communication an eye diagram, right? Also you can call it as a butterfly. Is it okay? Then let us consider if there are like this. That means if your output is like this, then definitely you should filter out all the DC components present. Then you have to pass about only the AC component. But if you observe, as I said previously, in this case you have some signal that is a bipolar signal. What should you have to do? You have to convert this bipolar into unipolar with some rectifier. Okay, if you consider like this output, if you observe the name of the figure, superposition of many sweeps, is it okay? if there are superposition of many sweeps like that, what should you have to do? You have to suppress these DC components, you have to allow only the AC components, and also you have to suppress one polarity, either a positive or negative polarity. That means you have to convert this bipolar into unipolar, right? Okay, that is a very important point here. To perform this concept, that means to suppress the DC component and to allow the AC component, and also, okay, and also to convert unipolar into bipolar, you have to use some block in your architecture. That means that block is nothing but delay line canceller. Okay, if you observe this MTI receiver with delay line canceller, right? You have to write this concept by your own with a own description. That means don't try to write with a that means what we'll call uh, don't try to write with a complicated words, just try to write with a, okay, easy words. If you observe this figure, there is a receiver. As I said, there is a bipolar video. Okay, if you observe this is a bipolar video, right? Okay, then if you observe this figure, first of all concentrate on this figure, MTA receiver with delay line. The bipolar video is transmitting to the subtractor circuit. Why? Because I said that at the mixer side we are going to consider only the difference component. It is directly transmitted, and it is transmitted with some delay line. That delay line, it is 1 by PRF, okay, pulse repetition frequency, reciprocal of pulse width, as we talk about pulse repetition frequency, right? Then after subtraction you have some bipolar, then you are going to use some rectifier to convert this into unipolar. Okay, this delay line canceller is going to be suppress your DC components by this concept. That means by transmitting your bipolar video with the delay line, that means with some delay and directly, then later they are going to subtract. Okay, this is coming as it is, this is coming with some delay. Then after that what happens means it is a constant one, it is not going to be vary, it is some, okay, delay one, it is going to be vary depending upon the pulse repetition frequency. Then easily your DC component is going to be subtract, only an AC component is going to be allow. From thereafter the bipolar video is going to be converted into unipolar. Okay, I said already the indicator we are going to use in radar is PPI, plan position indicator. Okay, the description here, if you observe this, the delay line canceller acts as a filter to eliminate the DC component of fixed targets and to pass the AC components of moving targets, right? The video portion of the receiver is here divided into two channels. If you observe, the video portion of the receiver is divided into two channels. One is like this, another one is with the help of delay, right? One is a normal video channel, okay, and the other video signal experiences a time delay equal to one pulse repetition period, equal to the reciprocal of the pulse repetition frequency. Is it right? The outputs from the two channels are subtracted from one another, as I said that, right? The fixed targets with unchanging amplitudes from pulse to pulse are cancelled on subtraction. Okay, however, the amplitudes of the moving target echoes are not constant from pulse to pulse, and subtraction results in an uncancelled residue. Is it right? The output of the subtraction circuit is bipolar. To convert this bipolar into unipolar, we are going to use some rectifier here. Full wave rectifier I am going to use. As you know that, as you are electronic student, you know what is the use of full wave rectifier than an half wave rectifier, right? If you observe once again, this video portion consists of the receiver. Okay, the receiver video portion is divided into two channels. One is a normal video channel, another one is a delay line equal to, okay, reciprocal of pulse repetition frequency, or you can say that which is equal to pulse repetition period. The outputs from the two channels are subtracted from one another. Okay, is it clear? If you observe the unchanging amplitude from pulse to pulse are cancelled on subtraction. Okay, then moving target amplitude are not constant, therefore they are not going to be cancelled. Then thereafter the bipolar video is going to be converted into unipolar with the help of what? Full wave rectifier. Okay, that's it regarding about introduction principle. Okay, if you are thorough with all this, then entire the syllabus is going to be very easy. Sorry, not a syllabus. Okay, syllabus of this unit is going to be very easy. Okay, just we will quickly recap what we have discussed. We have discussed about the introduction, that means what is a radar, why it is, then types of radar, CW, then pulse radar. Once again, pulse radar is divided into two types. Okay, MTI, moving target indicator, then pulse Doppler radar. Is it clear? Then after that we have went to the principle. Sorry, after that we have went to what is pulse radar. Okay, what is MTI radar, what is pulse Doppler radar. We have went to the principle of it. Then later we have went to the pulse radar description of operation, right? Pulse radar description of operation. Is it okay? In that we have considered some simple like this, some simple CW radar, and by adding some blocks to this we have converted that into a pulse radar. Then we have done some mathematical analysis, right? This is the V1 we have considered, this is the reference, this is the echo signal, then these are the okay parameters. Is it right? Then this is the final signal we are going to talk about, difference signal. Okay, is it clear? Here this addition concept is not considered. Why? Because we have said that we have preferred the difference frequency component. Clear? Okay, then after that we have went to some outputs depending upon the Doppler frequency shift. Some outputs we have considered. Then later we have uh, shown the output by separating the stationary and moving targets like this. Arrows indicates the moving targets, right? Then we have went to what happens if there is a superposition. Okay, then what happens? There is a butterfly in this. Is it clear? Then what should we have to do? Means we have to use some delay line cancellers to compress, sorry, to suppress the DC component of stationary objects to allow the AC components of moving objects with the help of this figure, right? Then we are going to discuss about MTI radar with power amplifier transmitter and with power oscillator transmitter. Clear? Okay.